Sí, venga, empezamos entonces. Sí. Pues nada, buenos días a todos y bienvenidos a esta conferencia que va a ser la última de un ciclo de conferencias que han impartido diferentes profesores invitados por la escuela dentro del programa que, como sabéis, está financiado por el Banco Santander. Son varios los grupos de investigación que han invitado a distintos profesores y hoy tenemos el placer de contar con Johann Fellner, que es profesor asociado doctor de la Universidad Tecnológica de Viena, es profesor en Gestión de Residuos en dicha universidad desde 2012 y director del Laboratorio Doppler de Recursos Antropogénicos. Colabora activamente en diferentes organizaciones nacionales e internacionales para la gestión de residuos, la conservación de los recursos, es responsable del grupo de trabajo para la implantación del sector académico en la ISWA, la Association International of Waste Solids, y editor adjunto de la revista científica internacional más prestigiosa en el ámbito específico de la gestión de residuos, que es Waste Management, como muchos sabéis, de la editorial Elsevier. Johann, thank you very much again for coming. Thank you very much for giving us your time during the whole week. It's a pleasure for this school and for the university to have you here. And he will give the conference entitled Potential and Limitations of Urban Mining and Circular Economy. And now Amaya, sorry, Spanish. Will introduce, Amaya presentará la conferencia y bueno, pues nos hará un pequeño resumen del contenido de la misma y ampliará pues la reseña bibliográfica que tú consideres. Muchas gracias, Amaya, por coordinar toda esta semana con él y organizar todo para que viniera y al grupo aquí en general.
Muchas gracias, Dani. Bueno, yo quiero comenzar agradeciendo al Banco de Santander, a la Universidad de Cantabria y a la escuela por la oportunidad de traer al profesor Fellner a trabajar una semana con nosotros. Yo creo que has hecho el resumen principal de la importancia que tiene Fellner en el campo de los residuos y de la economía circular. Simplemente es uno de los especialistas más reputados en este campo. Me quedaría añadir a lo que tú has mencionado, simplemente que tienen un grupo muy potente en el Instituto para la Calidad del Agua y la Gestión de los Recursos en la Universidad Tecnológica de Viena, que tiene numerosas publicaciones y participación en congresos de todo el mundo y que ellos se dedican a los mismos temas a los que nos dedicamos en el equipo de residuos del Grupo de Ingeniería Ambiental y por eso nos conocemos desde hace años. Ellos han recibido a doctorandos nuestros para estancias de investigación en su grupo y por ello estamos muy agradecidos. Hoy hemos pedido a Johann que nos hable sobre economía circular y minería urbana, que es un tema que está en ebullición en estos últimos tiempos, sobre todo, podríamos decir que en nuestra región, que en estos días se está echando a andar el Comité Asesor del Gobierno de Cantabria para Cambio Climático y Medio Ambiente, y en particular el Observatorio de Economía Circular y Bioeconomía, con lo cual yo creo que esta conferencia pues, es muy oportuna justo en este momento, ¿no? Lleva retrasada 2 años porque, como sabéis, el programa estaba previsto que en la escuela tuviese lugar hace 2 años, antes de la epidemia COVID, pero bueno, ha venido muy bien porque el tema es, si cabe, aún todavía de más actualidad. Well, I won't say anything else. I just want to thank Johann for being here and for telling us about circular economy. So, please.
So, the floor is yours.
Thank you. Yeah, thank you very much for the introduction, but thank you even much more for the invitation. It's a big honor for me to be here, to spend this week here, and I spent it already marvelous days since Sunday here, so I'm very happy and very thankful for the invitation. The topic today is about urban mining and circular economy, and what are the potentials and limitations. And you will see later on that I will focus very much on the limitations. And I'm doing that because a lot is promised what circular economy and urban mining can do, but very seldom people are talking about limitations, and that's quite important. The picture in the background should illustrate the way how we are used to get our resources, like from mines, okay, and probably how we're supposed to get in future our resources, basically by keeping them in the circle, by keeping those resources which we used in the past already as long as possible in our societies, and at the end of the life do urban mining, taking materials, resources out of those cities or out of those goods we are using. Yeah, basically I would like to touch these different keywords here during my presentation. I would like to talk about resource consumption, that we understand why we need urban mining, why we need circular economy, then also talk about resource scarcity. What is that? Why do we have resource scarcity? Do we have resource scarcity? Then talk a bit about resources in our cities which are somehow stored there. And then talk about what urban mining and circular economy can do. And at the final end, I will talk also about the case study in the city of Vienna on construction materials. Just to explain the term urban mining, I mean circular economy is probably more familiar to you, but what is urban mining? And there is another term which was used in the past very much. So I would say urban mining was a major keyword maybe 10 years ago. Now it's circular economy. Somehow they describe similar things, but I would like just to touch what we are talking about. So in our technosphere, meaning that's the opposite from the environment, we have resources in the urban area, in the rural area, and in the border between rural and urban area. So these are resources which are in use. So basically we would understand the room, the building here as a potential resource for the future. Because at a certain time point, even if the room looks very nice, very fancy, at a certain time point it will be renewed, or maybe it will be torn down and a new building will be built. So these materials in there are a potential resource. But at the moment they are still in use. Then we have in the city, and I will talk about that later also, we have materials which are not in use anymore, which have been used but are not in use, but they're in place. And many cities, and I guess the city of Santander has the same, there is a lot of infrastructure, for example, under the ground, cables, pipes, and at a certain time point, these cables and pipes are replaced by bigger, I don't know, for bigger voltage or for bigger amount of electricity. and very often these old cables are not removed because you would like to disconnect, you'd like to keep the time of disconnection very short. So you put the new cable, you leave the old cable as long as possible inside, and then you disconnect, and then the cable is very often left in there. So these are materials which are in the city, but which are not in use. Yeah. On the other hand, the other side, we have the landfills, so all the materials where we find out, okay, they are not worth to be recycled or we cannot recycle them. They are put on the landfill. And of course, technology changed over time. Probably what we were not able to recover from the waste could be recoverable today. So there was also this concept of landfill mining very much discussed and investigated. So urban mining would focus what is inside the city, and landfill mining definitely what is in landfills. So two pictures for this. And there are, of course, other resources which are out there, which are basically from the mining industry. So when we mine materials, they contain also some materials which we are not recovering, which are put on tailings, but I will not talk about this. Yeah. So it's about recovering resources from the city. Okay, but now come back to the resource consumption. This picture displays the overall resource consumption of a baby or a person from the childhood until he's dying in Northern America or in Western Europe, and it's about more than 1.1 million kilograms during all the lifetime. Okay, within the chart the data are given in tons, so the biggest amount is coming from construction materials, so about 500 tons of stones, sand and gravel. And then almost the same amount of fossil fuels, petroleum, so oil, natural gas, and coal. And then different minerals, cement, salt, different metal ores, phosphate rock, and so on. So a huge quantity of materials we are consuming. That's one issue. And another issue, which is specifically for the European Union, applies, is that the European Union, and I guess Spain has the same issue, for a lot of resources we are heavily dependent on imports. So there is no domestic production, or no domestic mining, so we need to import those materials. And I mean, some of them, okay, antimonium, cobalt, molybdenum, they are used in tiny quantities, yeah. But even what was surprising to me to see, that's unfortunately in German, iron ore. So the overall iron ore consumption of the European Union is to 85% imported. So we are heavily dependent also for very important metals, I mean, which we use in a high quantity. We are importing them. Also, the raw material for aluminium production, bauxite, the import dependency is 95%. So at a certain time point, and that maybe was already 10 years ago or a bit more, the European Union put the resource issue on a very high agenda. So different strategies have been developed, and one of them was to have like a partnership with some mining countries in Africa or other regions of the world, so to get a more stable supply of those resources. That was one issue. The other issue was about increasing the domestic production, simply because mining activity is usually, how to say, rather a dirty business with a lot of environmental impact. So at a certain time point, countries decide, okay, we will not do this job. It's too expensive also to do it in Europe. We just let it someone else do. So it was also some initiative to open old mines again and to have a higher domestic production. And the third one was to foster recycling and resource recovery in different names. Either it's called urban mining or circular economy and so on. So to keep the resources as long as possible in there. Yeah, and this has the main two reasons are, on the one hand, we are using a huge quantity of resources. On the other hand, we are heavily dependent on those resources. If we would have plenty of them, or if we don't need to import them, if we're not dependent on them, we would not talk about it. The next term I would like to discuss is about resource scarcity. I guess, did you hear about the term scarcity? Scarcity means that something is not available in a big amount. And I bring this newspaper article. It's already a bit old already. I could search for a newer one, but it was from 2008, just before the economic crisis. At this time, like today, commodity prices for raw materials boomed up. So the oil price at this time was about $120 or something. I don't know, today it's maybe even higher. Never mind. And this guy, Paul Krugman, he won the Nobel Prize for Economy, and he has, a weekly article in the New York Times. He was writing about this are we running out the planet to exploit, meaning do we have a limited amount of resources and prices are increasing, so there must be a sign that there is too less left to be mined and to be recovered. This discussion about are we running out of resources was not started 2008, of course. Yeah, I don't know if you're familiar with this, but 1970, I think, there was the Club of Rome, and they discussed already about the issue of limitations of growth and limits of the planet, and their resource scarcity was a very hot topic already. So this is what I know also from my studies. But then that was really surprising to me. I had this article in the New York Times, and then I started to search in the New York Times, and you can do that. You can search for keywords there, and you will get all the articles for a certain keyword back until 1890 or something. So really for more than 120 years or something back. So I did that, yeah, and I expected that resource scarcity will pop up in the 1970s, but then I was really surprised. Already in 1900, so 120 years ago, this topic was really a very hot topic. So I mean, I just tried to take out some of the articles, but most of the articles were just about 120 years ago about resource scarcity. And leading researchers, economists, and so on were really worried at this time there is too less resources. Never mind whether it's iron or coal scarcity or copper scarcity. So yeah, people believe that there's not so much resources out there. And at this time, the United States start to be getting electricity connection. Yeah. And people at this time believe there is not so much copper in the world to make all the United States be connected to the electricity grid. So that was like, for them, very sure. Yeah. We know, of course, that they were wrong in the past. Yeah, because basically, since this time, we increased production a lot. I will show you later. But we don't know what will happen in the next 100 years. Yeah, maybe they will love also about our worries. We don't know. Yeah. Just to show you what happened during this time from 1900. Okay, that's sorry, I didn't translate this. These are different commodities, and I guess for some of them you can guess what it can be. So it's oil, steel, copper, phosphate, lithium, coal, aluminium, cement, cadmium, and zinc. So different commodities. And what you see here is the global production from 1900 to 2010. And all the data, all the commodities are referred to their production in 1950. So all the curves are passing 1950 by 1. Okay? Meaning, for example, the blue line is aluminium. Since 1950, the global aluminium production has increased by factor 27. The annual production, okay? If we would refer to the year 1900, okay, which is far below 1 for many of them, we would see that the increase is really incredible. That's just the global production every year. And as I told you before, at this time people were very worried about what's going to happen in the future. But we don't know what's going to happen here on. And now I have a question to you, so that you don't fall asleep. What do you think is a good indication whether a resource is getting scarce or not? what do you think is a good indication whether we know that a certain resource is limited? I just talked about it a bit. Yeah. Any idea what? How can we see? Yes. Okay, you are thinking already a step further, yeah. But try to think very simple now. I mean, if you look to the price, simply the price. Okay. So I have another question now. What do you think happened with the price over time for those commodities? Any idea? Did it increase a lot? Did it decrease? Any idea about the price of those commodities over time? The question? The answer? The question? No, the question is, we have the different materials. We have oil, steel, copper, and the question is how the price for these materials developed over time. Is it increasing or is it decreasing? And decreasing? Increasing. Okay, increasing. Okay, who else is for increasing? Okay, the people who are not answering are sleepy already. So let's look to the next chart, and this chart shows now not the amount, but the price index, okay? And all the prices were referred to the price 1950 again. And of course, inflation was not was removed, so they have the same how to say nominal value of that commodity. Okay. And when we look to the graph, it was surprising for me also to see that over the long run, more or less, all the prices stay constant. You know, because I mean it's going up and it's going down. But if you look to the majority of those, I mean some of them, even for example, lithium, decreased a lot, yeah. And then, for example, for copper, we have much higher prices here. Okay, then it went down, then it went up again, then it went strongly down. Then before 2008, it went up again. So over the long run, prices did not really increase for most of the commodities. Is there any explanation for this? I mean, we know that with every ton of copper we take out there is less. There's less to mine, yeah. So definitely we are removing something. So what do you think is the reason that the prices didn't really get up so much or stayed more or less constant? Yeah. Yeah. So the major point is, I will show you later on that of course. At this time point, we mined materials which are much higher grade, so which are much higher content of the target material. So we just need to mine lower quantities of ore to get the material out. Today it's much more because the grade is lower in quality, but technology improved so much over time, which reduced the price, and also the scale of mining improved incredibly. Yeah. So this was acting as a counterpart to keep the prices more or less stable over the time. But people generally would have the perception that prices went up over time. Yeah? The only commodity where we would see really a higher price in the last quarter of the last century would be oil, the yellow curve. Yeah? This has some political reasons. Yeah? I mean, there are these high peaks were related to some political events. But in general, even far away from the political events, those prices are definitely higher than in the first part or the first half of the last century. So I'm trying to answer with you the question whether fossil fuels or oil is a limited resource. And you have all the time the discussion about peak oil, like there's a certain time point when we mined or have more than half of the oil already mined. And I would just try to tackle this question now. And I'm not just focusing on oil. I just would like to look to all the fossil fuels, okay? And I'm sorry that I can't answer the question at the end, but I'm trying to discuss the question with you. Okay, what you see here is different quantities of fossil fuels, and they are given in, what is that, billion tons of carbon. So fossil fuels given in billion tons of carbon. So from the beginning of the industrialization until 2007 or 2010, never mind, in total 500 billion tons of carbon, of fossil carbon, have been extracted via coal, oil, or gas. Okay? The blue bar shows this is the quantity of proven reserves which are out there, which companies have detected, which they checked, and they said, okay, we have the technology to mine it, and it's also economically feasible to mine it. Okay? So this is about 3 times the quantity we had in the past. Yeah, we extracted in the past. But this is just what we know and where we have the current technology to do that, and where the price is also okay to do that. Yeah, it's from a technological point of view, we know it. From a technological point of view, and also from an economic point of view, it's feasible. But the question and the geologists usually distinguish between the reserves, so they use the term reserves for those they know and which they can extract at a marketable price, and the resources. The resources is the total quantity out there, okay? But we don't know it exactly. So my question to you now again would be, how big would you estimate is this yellow bar in comparison to the blue bar? Is it 2 times as high, 3 times, 4 times, 5 times? Juan, any idea? I'm just checking if you're not sleeping yet. Yeah. Okay, so no idea, no estimates. No one is how to say is. You know, I don't know it either. Yeah, so don't worry. Okay, no clue. Okay, but there is. I mean, I said I don't know it, but there is at least some hint how we can assess how big it could be. Yeah, or it might be. And the hint is the following. We need to know how fossil fuels have been generated, okay? And this we can easily do when we look to our atmosphere, okay? Today in our atmosphere we have about 21% of oxygen and then some other tiny gases, tiny quantities of gases, and the majority is nitrogen, okay? If we go 1,000 million years back, we have a different atmosphere, yeah? We had very tiny quantities of oxygen. We had a lot of CO2 in the atmosphere, and the remaining part was nitrogen. Okay? And then at a certain time point, the atmosphere changed over time. So, a very easy question now. What happened that the atmosphere changed from a CO2 atmosphere to an oxygen atmosphere? What happened? What's vegetation? So photosynthesis developed, okay? That's the reason that it was possible to change our atmosphere, yeah? So the question is now, where is this carbon, okay, which was out there in the atmosphere, okay? And part of this carbon is here, inside the building, yeah? I mean, in our biomass, in our soil, okay, we have a certain amount of carbon. All the living goods, we have this carbon today, so this is quantifiable, how much carbon is there. It's also quantifiable how much carbon was that, roughly. Okay, based on this information. So, and some carbon is missing if we do this balance, okay? And this carbon has been somehow extracted from our circle, and this carbon most probably is in those fossil fuels in there, okay? And if we do this rough I did not invent this, it's not my idea, by the way. Yeah? If we do this rough calculation, we find out that this blue bar might have a value of 300,000 billion. So it's about almost 200 times higher than the blue one. So that means basically we probably won't be worried about the supply of fossil fuels because there is so much out there where we don't have the technology. Okay, but what will happen if we would extract it, and that's what we are doing currently already. We are step by step converting our atmosphere back to the old CO2 dominated atmosphere, which we cannot do. Yeah, I mean we are doing that very slowly. I mean very slowly. We are doing that very fast already. If we talk about geological time frames, so the main message here I would like to deliver when we talk about resource scarcity, and this is also something which relates to circular economy, to urban mining, that sometimes it's not the supply side which is scarce, it's the disposal side which is scarce. I mean, if we wouldn't have the CO2 problem in our atmosphere, I mean, no problem to use as much oil or gas or whatever, yeah. So we don't have in that case a supply problem with the fossil fuels. We have much more. I mean, currently we have with Russia some kind of supply problem, yeah, but this has a political reason. But overall, we do have in that case a disposal problem. So we have two less. We would call it not. We would call it as a sink problem, where to get rid of those materials which are generated. Yeah? This is very important to keep in mind. Okay, coming back now to some materials which is not distributed after use in the atmosphere, like fossil fuels, copper. I was talking about it already, and you see here the copper content, the average copper content in the ores which are mined. And you see we started 100 years ago with 4%, meaning if we take out 100 kilograms of copper ore, we get 0.04, or if you take 100 kilograms, we get 4 kilograms of copper. Today, the concentration is already 1% or even below 1%. So today, when we mine 1 ton of copper ore, we get 1 kilogram of copper. Yeah. Yeah, 100 kilogram of copper ore equals to 1 kilogram of copper. This copper is not lost, which has been mined in the past. And this picture shows you how this quantity of copper has increased. So this light blue curve gives the cumulative amount of copper which has been mined in the past already. Yeah? And it's of course increasing because every year we extract copper, and this copper is somewhere in our cities or somewhere in our laptops or somewhere in our landfills. Yeah? So it's not definitely lost. So we could still somehow recover it, yeah, with some effort. The dark green area gives the amount of copper which geologists report, which is out there in our copper mines, so the reserves which we can extract. Yeah? And this quantity, yeah, you would assume basically it should decrease over time, you know, because we extract something, so it should decrease. But simply, it's not like this, because every year or every time we discover new deposits, so this is the reason that sometimes the quantity goes up, yeah, because we discover new sites. On the other hand, it can go also down, as you see here, very quickly, and this is mainly related to the fact that these reserves are linked to the price of the commodity, because it could be that the mining site is at the current price, how to say, feasible to be mined because the price is high enough. But maybe if the copper price goes down a lot, then this mine is closed and not considered to be mineable. Yeah? That's the reason that we have these sharp decreases here. Or the other way around, it could go very sharply up if the price of the copper goes up. So some fields which have been not before classified as mineable get suddenly mineable. So this is the quantity outside. And I'm showing this graph just to illustrate you that the quantity which we have extracted equals more or less the quantity for copper which we currently know is in our resource deposits. So they are really on the same level of quantity already. Yeah? And this is of course getting more and more important. Yeah? So this definitely will increase in future. And at a certain time point, of course, we will have more copper in our, call it anthropogenic or urban mines, than we have outside in our ores. And this applies for other commodities as well. So we have a lot of resources in the city. This is it's again in German. This is a study which was done for Switzerland, where they try to classify how much of the different materials are used in Switzerland per person, or how are in use. And for example, the biggest quantities, of course, construction materials like sand and gravel. Then it was about 370 tons. Then about 20 tons of bricks. Steel 5 to 10 tons per capita. Wood 5 tons. Plastics 1 ton, and so on. So a huge quantity which become waste, which will become waste in future, and which represents a potential resource. We did a similar study for the city of Vienna, where we classified the resources in the buildings. Maybe I will talk tomorrow more about that, how we did that. And we came up with, but we just looked to the buildings, not to the infrastructure, so we came up with some other figures. The city of Vienna is a rather old city, so we have a lot of brick buildings there. So we have 100 tons of bricks, much more than in Switzerland. 85 tons of concrete, and this is everything per person. So every person statistically owns 100 tons of bricks, okay? Because basically all the buildings were divided through the 4 tons of wood and about 4 tons of steel, which are in use. And I mean, this should just display the size of a person in comparison to a cube of these materials. So, as I said before already, for the copper, when we compare those materials which are in our urban stocks with those which are in our mines, it might be in the same order of magnitude. For copper, 300 million to 600 million, so the same order of magnitude. For zinc, it's the same almost. For iron, much more is still in our mines, but still that's on an increase. So, in order this part to be managed, can probably save the extraction of other resources if we are thinking a bit smart about it. And I would like now to come to which obstacles are now when we talk about urban mining and circular economy. Okay, so we have a huge stock there, but the major problem now is most of this stock is in use. You know, you would not. If you are interested in wood, yeah, you would not tore down this nice lecture room just to get to the wood. Yeah? You need to wait until it's renewed or it's so old that someone decides to rebuild it or whatever. Yeah. So a lot of those resources which we quantify, or which I try to show you that is quantified, is not available at the moment. Yeah. It's just at the end of the lifetime. Yeah. But, and this is what I told you at the very beginning. Some of the materials are not in use anymore, yeah. So that it are maybe this, maybe there are some. I don't know if it's in Spain the same, but in Austria we have the issue that in the cities, of course, if a building is not used anymore, it's torn down, or if it's not usable anymore, because the space is so expensive. Okay. If we go to the rural area of Austria, you find a lot of old buildings which are not used anymore and which cannot be used anymore because they're not in a good shape anymore. But no one cares about it, and no one cares about the materials in there. They are just left how they are, okay? So this would be also potential resources, but inside the city, we do have a lot of infrastructure below the ground, which is probably not in use anymore. And there was a study, I'd like to bring this example from Sweden. There was a study done for a city which is maybe half the size of Santander, I think 100,000 inhabitants. And they investigated for all the city how much copper is built in the underground, yeah, below the surface, by analyzing different old maps and information about the local provider of the electricity net. So they generated this cadastre, and then they found out that in total there is about 2,600 tons of copper below the ground in cables. The majority is in use, so about 80% is in use, 2,100 tons is in use, and about 600 tons, almost 600 tons is out of use. Yeah? Which is 20%, and the reason there, and it's probably for many cities the same, at a certain time point this city changed from a direct currency to a, what is the opposite of a direct currency? The changing currency, you know what I mean, I guess, yeah? What's that? Altered currency, okay. So we did for some smaller cities in Austria similar studies and came also to the conclusion that between 10 to 15, sometimes up to 20% of the total cables below the ground are not in operation anymore. Okay, this 500 or 600 tons of copper can be easily extracted, and the price for copper is about 10,000 euros per ton. Okay, so this is about 5 million, 6 million euros, which is in the ground. Yeah. So in order to do that, you need to dig out the cables. Yeah? And then you need to compare what are the costs of digging it out with the revenues you get from the cable. Yeah? And there are basically different cables in there. There are cables in there which occur for a voltage of 0.4 kilovoltage. And this is the amount of money you can get per meter, the euros per meter, which is for this cable just maybe 5 euros or 8 euros. Yeah? If you have thicker cables, yeah, for higher voltage, it goes up to 20 euro. Maybe in the meantime, the copper price increased. Maybe in the meantime, we are already here at 30 euros, yeah, and maybe here about 15 or 10 euros. Yeah. So this is the money you can gain, yeah. And the question is now, how much money do you need to pay to dig it out? This is about 110 euros, yeah? Because you need to dig it out, and then you need to restore the surface again, which is quite costly. Yeah? So from that perspective, okay, the material is in there, but no one would think to touch it because it's simply too expensive. But if you know where are the cables, you can check whether there are some activities done in the street in any case, because some other activities need to be done, and you need to renew the surface of the street anyway. Then you can combine these activities and try to recover those materials. And there are some technologies out there which have been, how to say, tested in the meantime. I don't know whether they are applied in a large scale, that you could try to, how to say, maybe make a hole into the ground just every 50 or 100 meter, okay? And then come deep to the cable, and then cut the cable there, and then try to pull it out. There are some technologies, they use a certain type of oil. I don't know how is the environmental impact of that, yeah? I just can tell you what I heard about it. So they press in some oil between the plastics and the metal, and by this they can pull a certain length of at least, I think, 50 meters of the cable out there, which avoids to open all the street. Yeah. Okay. Yeah, that's another example. I would like to skip this one. Okay. So we have. I said before, one obstacle is that only part of the material is available, because otherwise it's in use. The second one are the costs, yeah, and the third one, which is getting more and more difficult, is we are facing an increasing complexity on the different levels for all the goods what we are producing. I hope you can read that. It's rather small. These are the amount of elements, of chemical elements, which have been used in printed circuit boards in computers, in personal computers. So we see in the 1980s, those 11 elements were used. Okay. 10 years later, 4 additional elements have been added, okay, to the recipe of the printed circuit boards. And in the 2000, I don't have now because there is not so much elements to be added anymore. But in the 2000 years, additionally 45 elements were added. So we have a huge mixture of different elements, and you can imagine, or it's no need to ask you, but of course here it was much easier to recycle than if you have this huge mix of different elements. Yeah? And this is something we face in very different sectors, not only in the electronic sector. We face it in the car sector, we face it in the construction sector. Products are getting more complex, having more different materials, which makes it much more difficult to recycle and keep the materials in a circle. And then very often it's claimed, okay, let's make the products more easy, or use less. Why we don't use again 11 elements, yeah? But then we don't have the performance what we would like to have, yeah? That's the big challenge, yeah? It applies, as I said, also to buildings. I mean, maybe this is a stupid example what I use here. This is an old building from Austria. This is a new building, which is probably not so typical because the idea is to show here we use bricks, wood, and maybe steel, and some mortar, yeah? Okay. This building is maybe consisting of steel and glass only, okay, so it's not the right example of what I would like to show, but today's buildings are much more complex because we have so many different layers in there. We have a lot of insulation in there, which is good on the one hand because we need less energy for heating. But when it comes to be demolished, and I have a picture now about demolishing old buildings and new buildings. These are two buildings in Vienna. This was built around 1900. So it was really bricks and the wood beams and maybe the windows, which were made from a wood frame and glass. So we have maybe 3 or 4 materials in there. And you see here, just by a simple device, by this machine bagger here, it is possible to divide the materials. So we have the wood here, which can be recycled, and you have the bricks, which can be somehow also recycled, yeah, to a certain extent. I will talk about it later. Yeah, it's easy to be dismantled. This is a very new building, which probably shouldn't have been demolished. It was just 10 years old. So after 10 years, they built the building. After 10 years, they demolished it again. And there we have all the different kinds of material in there, insulation material. From the value of the materials which were built in, this is much more expensive. So we have much more valuable materials in there. But as you can see here on the picture, it was almost impossible to separate this. Yeah. Which makes circular economy or urban mining very difficult. Yeah. And in order to do that, people need to think already when they are planning to design a building that at a certain time point it's coming at the end of its life. And we need to think how we can separate it, or that we just use materials which are easily separated, yeah? Can be easily separated. Okay, yeah, that's just another example. These are the old bricks. And these are new bricks which have some kind of insulation in there, yeah? Which again makes it more difficult when it starts to be torn down and to be recycled. Yeah, this 1900 should not appear now, but never mind. Another problem or issue is, and we talked about that yesterday already, is if we would like to establish a circular economy, a full circular economy, the supply and the demand must more or less be equalized. I mean, because keep the circle, I mean, to keep everything in a circle, how to say, if we have too less waste, yeah, to supply the resources we need, which still need a lot of primary resources. Yeah? And this example shows also that from a quantitative point of view, the blue part here shows the amount of construction materials annually needed in Austria in million tons. So this is 110 million tons of construction materials needed, and 8 million tons is the amount of construction and demolition waste. So if we would theoretically recycle everything, we just could supply 10%, yeah, of the demand. Because the economy, or how to say, our buildings are still on a growth. Yeah. This I can skip. This is a quantitative issue, and then comes another point in there is the qualitative issue. Okay. I told you before already. Today we are building different than how we built it 100 years ago. Okay. So imagine now if we don't have the quantitative problem. Imagine now that the same quantity of waste is generated, construction waste, as we need construction materials. Today our buildings look different. They need different materials. So you would not find applications for the materials which have been used. Because in the past a lot of brick buildings were built, yeah? But today we mainly build using concrete. So that's also a qualitative issue which is arising. Yeah? Which means that for some sectors circular economy is somehow limited because we are changing our products. Yeah? Another good example I feel is when we think about, we definitely are before a transition of the vehicles we are using. Maybe in 2030 or 2035, most of the vehicles on the market will be electric-driven vehicles. Okay. Today we have other technologies. Okay, we have fuel-driven cars. Yeah. If we would theoretically be able to recycle a car by 100%, yeah, we would not be able to generate out of it an electric-driven vehicle because we need batteries, which we didn't have before. We need a lot of copper, which is not required today. And the old cars maybe contain some stuff which we don't need in the new cars. Yeah. So every every transition of technology means also that it's getting more difficult to close the circle because we have a different material demand. So finally, I would like to talk about the case study of circular economy and construction materials. In Vienna, we try to analyze how we could improve circularity, circular economy in the construction sector in Vienna. So this is the map of Vienna. This is where the city center is here, and the university is here. Yeah, and I told you yesterday that when the university was founded 200 years ago, it was outside the city gate. Yeah. So, yeah. So in a study of a colleague of mine, we analyzed what is the amount of construction and demolition waste arising from buildings every year and from the infrastructure, like from roads, bridges, and so on. Okay, and you see until 1996, construction waste from buildings was going down, and then at a certain time point, it really boomed up a lot. So we have much more buildings which are demolished and constructed new, and this was mainly because at a certain time point the city started to grow a lot. Yeah, maybe within the last 20 years, the city of Vienna increased by the same amount like the population of Santander only, so 200,000 more inhabitants, and these activities lead to also the demolishing of certain buildings and construction of new buildings, and that's the reason why the quantity went up. For the infrastructure, we see somehow a different trend. So at a certain time point it was increasing, then decreasing, and then again increasing. So the overall generation, if you put it together during the last years, was about 1.8 million tons of construction and demolition waste, which equals about 1,000 kilograms per capita or 1 ton per capita. And the raw material demand, which is not displayed here, for new buildings and for new infrastructure was about 4 million. So the share or the difference between the demand and the waste generation was not so high at an Austrian level, at the Austrian level, but still more than double the amount of raw materials is needed in comparison to what the amount of generation which appears. We analyzed also the composition of the construction and demolition waste, and yeah. So okay, most of it is concrete, and then bricks, mortar, and so on. And some of the materials are even hazardous waste, which shouldn't be recycled, like asbestos, or some of the rock wool, which is definitely not to be recycled. Also the tiles, yeah, are basically not recycled, but just landfilled. But coming back to a bigger picture now, and we used this methodology yesterday already for the plastic flows, but we did that now also for construction management, construction materials in Vienna. And we see here at the very left side the raw material demand, which I said is 3.9 million tons. And these raw materials are divided about 2.7 million tons of concrete, 300,000 tons of brick, 200,000 tons of asphalt, and about 700,000 tons of gravel and sand. And then these materials are used to build new infrastructure and buildings. And at the same time, some of the buildings are demolished, and we have different waste streams. So we have waste concrete, we have debris from buildings which contain basically brick buildings. We have asphalt, and then we have waste, gravel and sand. And this is then managed, it's collected. Part of it is sent for recycling, okay? And the other part is going to landfill. So about 400,000 tons are landfilled, and the remaining part, which is about 1.5 million tons, is going to be recycled. But most of the material is then somewhere ending up not inside the city, but just in the rural area for some road construction or something like that. Yeah. Very few material is really sent back. It's basically just asphalt, which is so. For the first two, we have only primary raw materials used. So for concrete and brick, we have just primary. And for the other, for asphalt and gravel, we have a significant share of recycled material in there. Meaning that the circularity rate for the city is about 10 to 15% only, yeah? Because this is really covered by secondary materials, which are coming from the construction sector, from the demolition waste, and the major part is just primary material. Meaning also that the raw material demand from the 3.9 million tons, the majority, between 3.3 to 3.6 million tons, is coming from primary materials. So this is the status quo, and we try to analyze what we can do to increase the circularity rate and to decrease the rate of primary raw material demand. So we developed some scenarios where we try to implement different technologies, which can make out of concrete recycled concrete. Yeah? But this recycling concrete needs also to be demanded by the construction companies. Yeah? Because you cannot, you cannot generate a secondary raw material and then you don't have the market for this. So, but based on the quality of the materials, it would be possible to generate out of the waste 500,000 tons of recycling material for waste concrete. Also from the debris, we could get some recycling material for fillings and so on within the city. Then part of the bricks can be reused, but this is quite a rather tiny part. And then the asphalt, which is already recycled, should be further recycled, and also the waste gravel, which is also to a certain extent recycled already. So it's basically the first three streams which are new. And by this we could reach a circularity rate of 47%. And the raw material demand of primary raw materials could be reduced from 3.9 million to 3.3 to 3.6 to 2.5 million tons a year. Okay. What we detected during the study was, in order to increase, reduce the primary raw material demand, we should foster more renovation instead of demolishing old buildings. We should also specify the share of recycling materials in new constructions. I mean, In some European countries, there is a large demand now for recycled PET material because, I don't know, the public is more aware about plastics recycling, so companies would like to deliver the information, this bottle has like 50% of recycling material in there. This is not the place, this is not the case for construction companies so far. Okay? So there must be some kind of more awareness and market for those materials in order to create the demand for those materials. Yeah? And this could be done by defining a certain share of recycling materials. In Switzerland, there is some provinces, if the government, the local government is building a new school or a new office building or whatever, in their announcement for that building, they specify they would like to have 20% of recycling material in there. Yeah. And if you have this market, this demand, then the recycling technology will be there also. Yeah, and recycling concrete is something which can really be made. So it's not something which is applied already in many countries, which is not done so far in Austria or in Vienna. And this could increase the circularity a lot. The brickwork or the debris from the brickwork could be utilized in the cement industry. The cement industry uses today a certain mixture of limestone and clay to make cement out of it. And instead of clay, they could use the debris from the bricks, because the bricks is basically clay, but burnt clay. Yeah. Yeah, and to maximize, this is already more or less done, maximize the recycling of waste asphalt, and yeah, some of the bricks. I showed you one of the picture with the nice, old eagle in there. Shape is sometimes used for certain decoration purposes. Yeah, so this material can be used again, but this has a minor impact. Okay, that was it from my side. I still see awake people, so I'm quite happy, and muchas gracias.
Algo sobre... Si lo querían pedir que utilizasen el micrófono para que se pueda escuchar la grabación.
Okay. I'm on, please. Yes, yeah. I know the plastic is an derivative from petroleum company. But my question is, there any technology to become the plastic to fossil fuel? Okay, I repeat. Is there any technology to become the plastic to fossil fuels?
Transform the plastic to oil again, yeah? Yeah, okay, there is the technology, and people are researching now on the fact to make out of plastics oil again, yeah?
Okay.
Yeah.
Okay. Thank you so much.
You're welcome.
Coming back to the more or less the beginning of the lecture, I'm worried about what you were saying about the amount or the amount of resources, mostly related to fossil fuels, that we know we can extract right now, and how that is related, or how can we relate that to the expected consumption in the following years, given that the growth is taking quite an exponential shape.
Yeah, I mean, I can only hope that we are smart enough that we know, okay, we have a certain budget of CO2 we still can emit. I don't know it exactly now, but I mean, to reach the 2% goal of 2-degree goal of climate change, we have a certain budget, and we are consuming it in a historical not historical, in a very crazy way. Yeah, we can only hope that at a certain time point we are really smart enough to follow the path which is out there. What we know, okay, at a certain time point we need to come to a zero CO2 emissions, and I mean, somehow I'm optimistic because I see there is some changes going on. For example, some of the, I mean, that's just a small sector, but some of the waste incineration plants start to think about implementing carbon capture. And there is one in the Netherlands already, and I think one in Norway, which is doing that. The big company in Vienna is also now having a feasibility study of implementing carbon capture. So there are technologies out there which can help us, but on the other hand, we must be very much afraid that the movement to implement this technology is far too low. Yeah. Yeah.
Okay, I can continue. I have also one question. Related also to the comparison between resources and reserves of fossil fuels. How it depends on the availability and complexity of how can the resources become reserves, and how it depends, what is your opinion about it? How it depends on the investment of companies, because I have heard that in the last years the big companies are reducing the investment in finding those resources that are available.
But that could be, that's a good, I mean, that could be a good sign that we are not using so much of those anymore. If the, how to say, if the investment is going down, that's a good sign that we are on the right path, because we don't need to find more sites or more places for mining. Of course, if you, how to say, we discovered that for oil, but also for copper, if you have a period, I mean, for oil it's somehow clear, and for fossil fuels it's somehow clear we need to phase that out to a certain extent. So there must be a period where we phase out, or we need to come down with the consumption at a totally different level. But before, in the past, or when we talk about copper, when we see the periods where the prices go up crazy, then you find all the companies going out there to investigate and to search for new places and to invest a lot of money, because they know they can make a lot of money out of it. So of course this is very much interlinked. There's a strong linkage between the resource becomes a reserve with regards to the price, of course, and the investment which is currently done.
Hello, Johann. What's your opinion about rare earth elements?
Okay. Yeah. Okay. Thank you. That was another, how to say, maybe also 10 years ago, there was a very big boom about rare earth elements and about the supply of those elements, because at this time period, China was having a kind of export ban of those materials. So everyone got crazy. I would say that the overall supply of those materials is not limited. I mean, we have just a few countries which are producing it. I mean, now it's not China it's not only China anymore. I mean, China is the main producer of those materials. Now it's how to say, also Australia, I think United States, another country, I don't remember now, are producing those materials, and we need them for some of the new technologies. For example, when we talk about more windmills, we need neodymium, for example, which is used for the permanent magnets in this. So according to what the US Geological Survey suggests, there is plenty out of it, plenty material out there. So we don't need to be worried about, how to say, that we don't have enough there, but probably the distribution, the global distribution, is very unequal. And if a certain country decides not to export these materials, then we might face a problem. But from the overall availability, global, it should not be an issue. Even if it was like as I said, 10 years ago, everyone was researching about recycling of those materials. Yeah? Yeah. Yeah. And then some companies, I know it from an Austrian company, they got the material illegally from China. I don't know how they did it, but they were still producing the same quantities of outputs they had before. Yeah. So they find some ways. Yeah. I don't know how. Yeah.
Related to the latest part, urban mining and circular economy, which was the main part.
Yeah.
Yes. How can we absorb, let's say, in the because you said that logically circular economy implies a similar demand as
no, I mean
the offer we have.
An ideal circular economy would imply that we have similar demand and supply from a quantitative and from a qualitative perspective.
That is. So how can that absorb both the, let's say, the economic growth, which in the end implies higher demands, and the population growth?
No, it doesn't match together. Yeah, it doesn't. I mean, for me, circular economy is a nice buzzword, and it's okay to move to a more circular society, but we will never close the circle. Yeah, yeah, definitely.
Okay, thanks for the presentation.
Yeah.
First of all, I have two questions. One about the CO2 budget.
Yeah.
Did you consider the biosphere or the CO2 that is dissolved physically in the ocean or something like that?
Yeah, this is also, I mean, I did not do the calculation, as I said before. It was taken from a study, I don't know, from the 90s or something, yeah. So they considered also this quantity, yeah.
Okay, and the second one is, yes, I want to know your opinion about when you saw us the price to extract the copper.
Yeah.
That is, I think I saw 110 euros per meter.
Oh, the cables, yeah.
Yeah.
Yeah, okay, yeah.
What do you think that what is the most possible scenario, that the price increase and then we are able to extract, or the technology are going to improve to extract in a lower cost?
I think how to say, both of them might happen. I mean, on the one hand, technology will improve. As I told you, there are some technologies out there which try not to dig out the whole street, but just to make every 50 meters some holes. So this will change. But for the time being now, I think the most important or the most easiest thing is to implement, all the time. I don't know, probably it's the same here all the time. There is some construction work going on, yeah, because I don't know, any company is just adding another cable or another infrastructure, yeah. And if these companies, which are how to say, are managing the grid below the earth, would be better linked together and would better communicate together, then I think we could do that without new technology extracting the old cables.
So
it's just a kind of management between the different operators of the grid. Yeah?
So the city mining have to be supported by another city activities.
Exactly. Yeah.
And implementing the process to renew the city.
Yeah.
Okay. Thank you.
Just thank you for such interesting and such clear presentation.
Thank you. Thank you.
Simplemente ya, por decirlo en castellano, aunque seguro que él también lo quiere decir, muchas gracias por haber venido y también por vuestras preguntas tan interesantes.
Thank you. Thank you again. Thank you. Disconnect this. Okay, I finished. Thank you. Thank you.